Okay, I'm going to go over the test review here for the trig test. So for the first 10 questions, we're going to be finding the value of the trig function indicated. So if you want to see the examples that we did in class, look at this worksheet here that I've posted on the screen. All right, so you can look at that worksheet on your own, and so you can see all the steps that we take, but I'm going to go over some of these. So we want to find the value of the trig function indicated, and I recommend that when you start your test that you write SOHCAHTOA. Right? SOHCAHTOA is going to remind us when we're going to use sine, cosine, or tangent, and then remember to write this at the beginning of your test as well. So sine, the reciprocal is cosecant. The reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So whenever you see this, it's going to be the reciprocal of this, right? So tangent is opposite over adjacent. So if you're looking for cotangent, it's going to be the reciprocal. So it's going to be adjacent over opposite. You just switch the values. All right, so for number one, we got secant theta. So we're looking for secant theta. So let's look back to our notes over here. Secant is a reciprocal of cosine. So that means that if cosine is adjacent over hypotenuse, secant would be the opposite, hypotenuse over adjacent. So I'm going to go over here, and I'm going to write secant theta is equal to hypotenuse over adjacent. That's the trig ratio. So here is our angle. So you're always going to look to see where your angle is to see what sides you are given in reference or in relation to that angle. So we're given the opposite side, right? But we don't need this. We don't need this side for our answer. We do need it to figure out what the hypotenuse is, but we're also given the adjacent side. And remember, the adjacent side is the side that forms the angle with the hypotenuse. So this is the hypotenuse right here, and this side forms this angle with the hypotenuse, so that's how we know it's the adjacent. All right, so we need to figure out what the hypotenuse is. So we're going to use the Pythagorean Theorem. Pythagorean Theorem is a squared plus b squared is equal to c squared. So what we're going to do is we're going to replace these values with what we know. We're looking for the hypotenuse, and it's important to know that the hypotenuse is always c, right? So we want to make sure that this is what we're solving for, so we can get the correct answer. If you don't put the hypotenuse here, you're going to get the incorrect answer. So I'm going to replace a squared with 8. I'm going to replace b with 15. So I have 8 squared plus 15 squared is equal to c squared. So you're going to do this on your calculator. 8 squared is 64. 15 squared is 225 is equal to c squared. All right. So 64 plus 225 is going to give us 289. So now to solve for c, we're going to take the square root of both sides, right? So when we take the square root of 289, we get 17. So you can do all this math on your calculator. So our hypotenuse is 17. So now we can label things. So this is hypotenuse, this is opposite, and this is adjacent. For our ratio, our final answer, secant theta is equal to hypotenuse over adjacent. Hypotenuse is 17, so I'm going to replace this h with 17. And then adjacent is 8, so I'm going to replace this a with 8. So this is our final answer, 17 over 8. On the test, it's multiple choice, and it's only going to be the fraction, right? So the answer is not going to have this. It's just going to have the 17 over 8, so you'll know which one to select. And on the test, our answers are going to, or the options are going to be in simplest form for your fraction. So make sure that if you can simplify your fraction, to do that. All right, so cosecant theta now. So let's look at what cosecant is. Cosecant is the inverse of sine. So if sine is opposite over hypotenuse, cosecant would be hypotenuse over opposite. So we're missing the hypotenuse, so we're going to do the same thing. We're going to use Pythagorean Theorem to find the hypotenuse. So 12 squared plus 16 squared is equal to c squared, right? So 12 squared is 144, and 16 squared is 256. So 144 plus 256 is equal to c squared. 144 plus 256 gives us 400. So we get 400 is equal to c squared. You take the square root of both sides, and then c is equal to 20. The square root of 400 is 20. So our hypotenuse is 20. So now to write my answer, I'm going to write cosecant theta is equal to hypotenuse over opposite. So my hypotenuse is 20, so I'm going to replace that h with 20. And the opposite side to this angle, right here, so here's the angle. The opposite side to it is the 12 side. So I'm going to replace the O with 12. So I won't see this option as an answer because it's not in simplest form. 20 and 12 can be evenly divided by 4, right? Both of those numbers are evenly divisible by 4, so we can simplify it. So our final answer, cosecant theta, is equal to 20 divided by 4 is 5, and 12 divided by 4 is 3. So this is the option that you're going to see on the test, 5 over 3. All right, next we're going to go to number 3. So here's our angle. And we're doing sine, so look at your notes again. Sine is opposite over hypotenuse, right? So this is how SOHCAHTOA is going to help you figure out what you need to do in case you don't remember it. So opposite over hypotenuse. Opposite over hypotenuse. So here's our angle. We're actually given the opposite side and the hypotenuse. So you'll know what the hypotenuse is because hypotenuse is always the longest side, and it's opposite to the 90-degree angle. So you see it's opposite to 90-degree angle. So this is our hypotenuse. And this is our opposite side. So we don't need to do Pythagorean Theorem. We just can write sine theta is equal to opposite, which is 8, over hypotenuse, which is 10. And we can simplify that. Sine theta is equal to 8 and 10 are both evenly divisible by 2. 8 divided by 2 is 4. And 10 divided by 2 is 5. So this is the option that you're going to see, 4 over 5. All right, now we're going to go over cotangent, number 4. So number 4 tells us to figure out what cotangent theta is. So cotangent theta, cotangent is the reciprocal of tangent. So since tangent is opposite over adjacent, we're going to do adjacent over opposite for its reciprocal. So cotangent theta is adjacent over opposite. All right, so here's theta. This is the hypotenuse, and this is the opposite side. So we need to figure out what adjacent is. So we're going to use Pythagorean Theorem again. So a squared plus b squared is equal to c squared. Now it's important to remember that this time we're given the hypotenuse, so that's what we're going to replace c with, right? So a squared, I'm going to write 15 squared plus b squared is equal to 18 squared. You got to make sure that you put your hypotenuse over here. If you were to put your hypotenuse here, you would get the incorrect value for the adjacent side. All right, so 15 squared is 225 plus b squared, and then 18 squared. 18 squared is 324. So we write that over here. Now to solve for b, we're going to first subtract 225 from both sides. And we get b squared is equal to 99. So now we need to take the square root of both sides to get b by itself, and I get b is equal to the square root of 99. Let me bring that over here. So b equals the square root of 99. So we need to simplify the square root of 99. And the way to do that, we need to see which one of the perfect squares 99 is evenly divisible by, right? So 99 is evenly divisible by the perfect square 9, right? So we can split this up into the square root of 9, and 99 divided by 9 is 11, right? So this becomes the square root of 9 times the square root of 11. So the square root of 9 times the square root of 11, and 11 can't be simplified any further, and 9 is a perfect square. So this is going to be our radical in simplest form. So the square root of 9 is 3, and so this is the 3 times the square root of 11. So that is our adjacent side. All right, so now we can write cotangent theta. So cotangent theta we wrote is cotangent theta is adjacent over opposite. So the adjacent side is 3 times the square root of 11, and the opposite side to this angle is 15. So we get cotangent theta is equal to 3 times the square root of 11 over 15. Now, this is not going to be the option that you see because this can be simplified further. 3 and 15 are both evenly divisible by 3. So the final answer that you're actually going to see is cotangent theta is equal to 3 divided by 3 is 1. So we're just left with the square root of 11 on top. And 15 divided by 3 is 5. So this is the option that you're going to see. Square root of 11 over 5. All right, so for number 5, I'm doing cosine theta. So here's theta. So let's look at our notes, and it says that cosine is adjacent over hypotenuse. So we need adjacent side and the hypotenuse. Well, we're missing the hypotenuse, but we do have the adjacent side, which is 5. So now we need to use Pythagorean Theorem to find the hypotenuse. So 5 squared plus 12 squared is equal to c squared, right? So 5 squared is 25, and 12 squared is 144. So 25 plus 144 gives us 169. And if we take the square root of 169, we get 13. Oh, whoops, sorry. This is supposed to say equals c squared, right? So now 25 plus 144 was 169 is equal to c squared. We take the square root of both sides, and the square root of 169 is 13, so we get 13 is equal to c. So this is our hypotenuse. So now what we're going to do is we're going to write cosine theta is equal to adjacent over hypotenuse, right? Adjacent over hypotenuse. Adjacent side is 5, right? Here's our angle, and here's the adjacent side. So 5 over 13. 13 is our hypotenuse. And that's how we get cosine theta. All right, now tangent theta. We're given this angle. And tangent theta, if you look at your notes, opposite over adjacent. Opposite over adjacent. And we're actually given the opposite and the adjacent side, right? So here's our angle. Here's the opposite side, and here's the adjacent side, right? It forms the angle with our hypotenuse. So we don't need to do Pythagorean theorem. We can just write tangent theta is equal to opposite side, 15, over the adjacent side, which is 8. So 15 over 8 is our answer. For number 7 through 10, what you're going to do is you have to draw a triangle first. So for number 7, it asks us to find cotangent theta if sine theta is equal to 3 over 5. So we're going to draw a triangle. Right triangle right here. And you can put the angle either here or here, whichever one you want. You just got to make sure you label it correctly after that. So if I put my angle here, that's theta. And so we know we have sine theta, right? So sine theta, if you look at your notes, is opposite over hypotenuse. So here's the angle. In reference to this angle, this is the opposite side right here. So 3 is opposite, and then hypotenuse is going to be the longest side. It's also opposite from the 90-degree angle. So this right here is the hypotenuse of 5. So now we're looking for cotangent theta. And cotangent theta is going to be adjacent over opposite. So cotangent is the reciprocal of tangent. Since tangent is opposite over adjacent, that means that cotangent would be adjacent over opposite. So we need to find what the missing side is, and then we'll be able to give cotangent theta. So we're given the hypotenuse. We're going to use the Pythagorean theorem. So we're going to do 3 squared, which is going to be this side right here, plus b squared, which is the missing side, is equal to the hypotenuse squared, so 5 squared. All right, so 3 squared is 9. 5 squared is 25. I'm going to subtract 9 from both sides. So we get b squared is equal to 16. Then you take the square root of both sides, and you get b is equal to 4. So our missing side is 4. So now we can write what cotangent theta is. So here's our angle. First, let's fill in the adjacent side. So remember, the adjacent side is the side that forms the angle with the hypotenuse. So it's going to be right here, 4. So I'm going to replace the a with 4. And then the opposite side is 3. So I'm going to erase that. And I'm going to put in 3. So that is our final answer. And the option that you're going to see on your test is just 4 over 3. It is in simplest form. All right, so for number 8, it tells us to find cosine theta if cotangent is 4 over 3. So same thing, you're going to draw a triangle. So here's our triangle, and cotangent is 4 over 3. Well, if you look at our previous answer, it's the same triangle, because we have cotangent is 4 over 3. It was the same over here, so that means it has to be the same triangle. So we'll do the same angle right here, theta. So cotangent is adjacent over opposite. So the adjacent side is going to be 4. The opposite side is 3. And our hypotenuse is 5. So now we're looking for cosine. Cosine theta is adjacent over hypotenuse. So that means that cosine theta is equal to the adjacent side for the angle is 4. And the hypotenuse is 5. So it's 4 over 5. So that's how we get number 8. For number 9, it asks us to find cosecant theta if secant theta is 5 over 4. So secant theta is 5 over 4. If we look at our notes, secant is a reciprocal of cosine. So cosine is adjacent over hypotenuse. So secant would be hypotenuse over adjacent. So we're going to draw a triangle. And the hypotenuse is going to be the longest side right here. That's 5. We can put the angle here. That's theta. And we have the adjacent side. So that means that this is 4 right here. If you look at it, it's the same like our other triangles. So that means that this side is 3. So now we can figure out what cosecant is. So cosecant is a reciprocal of sine. Right, if you look at it over here, sine is opposite over hypotenuse. So that means that cosecant is a reciprocal. So it'd be hypotenuse over opposite. Cosecant theta is equal to the hypotenuse, which is 5, over opposite, which is 3. So 5 over 3. All right, and then number 10, it tells us to find secant theta if cosine theta is equal to 4 over 5. So you don't even have to draw a triangle for this one because secant is a reciprocal of cosine, right? So look at your notes. Secant is a reciprocal of cosine. So if cosine is adjacent over hypotenuse, secant is going to be hypotenuse over adjacent. Secant theta is equal to, so we just write the reciprocal of 4 over 5, which is 5 over 4. That's your answer right there. For numbers 11 through 14, it tells us to find the measure of the side indicated, and then we're going to round to the nearest tenth. So you're going to need your calculator for this section, and what we're going to do is we're going to look at what information we're given, and then we're going to set up a function so that we can solve for our missing side. So we're finding the measure of the side indicated, and it's indicated with x. So we need to find out what this side length is. So first we're going to look at our angle. So we're given this angle right here, and we want to determine what sides we're given in relation to this angle. So this right here, this is the hypotenuse, right? Hypotenuse is always the longest side, and it's opposite to the 90-degree angle. And then this side right here is opposite to the angle that we're given. So we're given opposite and hypotenuse. So the trig function that uses opposite and hypotenuse is sine. So we're going to write this out in terms of sine. So sine theta is equal to opposite over hypotenuse. So we already know what sine is. Theta. Theta is our angle, which is 68 degrees. And we know that the opposite side is x. So we're going to write x over, and the hypotenuse is 12, so x over 12. Sine of 68 degrees is equal to x over 12. So now what we want to do is we want to get x by itself. To get x by itself on this right side, we're going to multiply both sides by 12. When you have a fraction and you multiply it by the denominator gets canceled out, and you're left with just the numerator, right? So we're left with 12 times sine of 68 degrees is equal to x. So now this is what you're going to type into your calculator. You're going to go to your calculator. You want to make sure that you click mode first before you get started, and you want to make sure that your degrees is highlighted. So here it's highlighted in pink. If I go away from it, it's highlighted in black. So you want to make sure that degrees is highlighted, because if not, you're going to get the incorrect answer. So we're going to type 12 times sine of 68 degrees. Click enter and you get 11.12. And it tells us to round to the nearest tenth, so we're going to round to one decimal, so 11.1 is equal to x. So here's our answer right here. So for 12, 13, and 14, you need to first identify which trig function you're going to use based on the information that you're given. So let's look at number 12. And for number 12, the angle is right here. This is the angle that we're given. On the test, none of the angles are going to be in the center. I know that one can look a little confusing since it's on the center, but on the test, none of them will be like that. So we're given theta, we're given the adjacent side to theta, and the opposite side to theta. So the trig function that uses opposite and adjacent is tangent. So we have tangent theta is equal to opposite over adjacent. So this is the opposite side, this is the adjacent side. So we write out tangent theta, which is 15 degrees, is equal to opposite, which is 13, adjacent, which is x. So in class, I've showed you guys the trick that we use here, or the shortcut where you're just going to switch x and tangent of 15 degrees. But I'll show you guys the long way for this example, and for the rest, we'll just work with the shortcut. So we want to get x by itself, and x is in a fraction, so we have to get it out of the fraction first. So we want to multiply both sides by x so that we get it out of the fraction. So now we're left with x times tangent of 15 degrees is equal to 13. Now x is out of the fraction, but now it has tangent here. So what we're going to do, we want to get rid of tangent of 15 degrees. So we're going to divide both sides by tangent of 15 degrees. So these cancel each other out. And now we're left with just x on the left side. You get x is equal to 13 over tangent of 15 degrees. So this is what you're going to type into your calculator, 13 divided by tangent of 15 degrees. So type in 13 divided by tangent of 15 degrees, and you get 48.51. So we'll round to one decimal, 48.5. 48.5. So the missing length right here, the adjacent side, it has a length of 48.5. All right, now number 13. So again, we're going to look at the angle. We're given this angle right here. We're given the hypotenuse and the adjacent side to the hypotenuse. So the trig function that deals with adjacent and hypotenuse is cosine. So we'll write cosine theta is equal to adjacent over hypotenuse. So cosine, we know that theta is 37 degrees. the adjacent side is 7, and the hypotenuse is x. So again, it's the same as number 12, where we have to multiply by x and then divide both sides by the trig function. But this time we're just going to use the shortcut, and we're just going to switch cosine and x. So x is equal to 7 over cosine of 37 degrees. You're going to go into your calculator, you're going to type 7 divided by cosine of 37. 7 divided by cosine of 37. And you get 8.76, so we'll write 8.8. All right, so now number 14. We're given this angle right here. This is the opposite to the angle and the adjacent side to the angle. So we're going to use tangent again. So tangent theta is equal to opposite over adjacent. Tangent, we know that theta is 34 degrees. The opposite side to the angle is x. And the adjacent side to the angle is 7.2. This time x is in the numerator, so all we have to do is get rid of the denominator, and we'll be able to solve for x. So multiply both sides by 7.2 to cancel it out here. And we're left with 7.2 times tangent of 34 degrees is equal to x. So we're going to type in our calculator 7.2 times tangent of 34. Times tangent of 34, and we get 4.85, so we'll round to 4.6. Sorry, 4.9. 4.85, we round to 4.9. So 4.9 is equal to x. For numbers 15 through 18, we're going to find the measure of each angle indicated, and we're going to round to the nearest tenth. So before I show you guys that, if you want to look at the worksheet that goes with the lesson on finding the measure of each side indicated and finding the measures of the angles, look at the worksheet that I put up on the screen. All right, so let's get started with number 15. So number 15, we're given this angle right here. That's the measure that we want to find. And in relation to this angle, we're given the adjacent side. We're also given the hypotenuse. So we want to use the trig function that uses adjacent and hypotenuse, and that is cosine. Cosine theta is equal to adjacent over hypotenuse. So now we're going to rewrite this equation, or this function. So cosine theta is equal to the adjacent side, which is 8, and the hypotenuse, which is 12. So what we want to do now, we're looking for theta, so we want to get rid of cosine. And the way to get rid of cosine is we're going to take the inverse of cosine, and we're going to do that operation on both sides, because whatever we do to one side of the equation, we have to do to the other, right? So if I do the inverse of cosine operation on the left side, inverse of cosine and cosine cancel each other out, and we're left with theta on the left side. So theta equals, and since we did the inverse of cosine to the left side, we have to do it to the right side as well. So we get left with theta is equal to the inverse of cosine of 8 over 12. So that's what you're going to type into your calculator. We're going to go to our calculator, and we're going to type in secant and cosine. That'll bring up the inverse of cosine function of 8 divided by 12. And we get 48.18. We're rounding to one decimal, so we'll do 48.2. So theta is equal to 48.2 degrees. For number 16, we're gonna take the same steps. So we have theta right here, and the sides that we're given in relation to this angle is the adjacent side and the opposite side. The trig function that uses opposite and adjacent is tangent. Tangent theta is equal to opposite over adjacent. So we're going to do tangent of theta is equal to, the opposite side is 13.6, and the adjacent side is 4. So we're going to use the inverse of tangent function. These are going to cancel each other out, and on the left side, we're left with the inverse of tangent of 13.6 over 4. So now that we know that, all you have to do when you're at this step, so I'm going to replace opposite and adjacent over here. So opposite is 13.6 over 4. So all you have to do to write in terms of theta is you're going to get rid of tangent. You have theta is equal to the inverse of tangent of 13.6 over 4. So you can just do that from now on. Now that in number 15, I showed you why we end up with that. Okay, so you're going to go to your calculator. You're going to type in the inverse of tangent. So that's secant and tangent of 13.6 over 4. 13.6 divided by 4 in the parentheses. You click enter and you get 73.61 or 73.6 degrees. So theta is equal to 73.6 degrees. All right, so for number 17, we're going to find the trig function that we're going to use. So here's theta. We're not given the hypotenuse. We're only given the opposite side and the adjacent side. So we're going to use tangent again. So tangent theta is equal to opposite over adjacent, so 6 over 5. And we're going to rewrite this in terms of theta. So we're going to write theta is equal to the inverse of tangent of 6 over 5. So you're going to type that into your calculator. So click secant and tangent, 6 divided by 5 in parentheses, and you get 50.19. So we'll round to 50.2 degrees. Theta is equal to 50.2 degrees. All right, for number 18, we're given theta right here. And again, we're given the opposite side and the adjacent side. So we're going to use tangent again. Tangent theta is equal to opposite over adjacent. The opposite side is 12. The adjacent side is 5. Now again, to rewrite it in terms of theta, we're going to write theta is equal to the inverse of tangent of 12 over 5. So we're going to go back to our calculator. Secant and tangent, 12 divided by 5. Yep, that was a ratio. You click enter and you get 67.4 degrees. Theta is equal to 67.4 degrees. All right, so now for numbers 19 through 21, we're going to be converting degrees measures into radians. So whenever you have degrees, the way that you're going to convert to radians is you're going to take your degrees and you're going to multiply by pi over 180. And then you'll simplify your fraction, and that'll be your measure in radians. So for number 19, you're going to first turn your degrees into a fraction by just putting 1 underneath. 315 divided by 1 is still 315, except it's in fraction. And we're going to multiply it by pi over 180. So when you're multiplying fractions, you multiply the numerator times the numerator and the denominator times the denominator. So 315 times pi is 315 pi. And then 1 times 180 is just 180, right? So now we have to simplify this fraction. We have to simplify 315 and 180. 315 and 180 are both divisible by 45. But if you didn't know that, or you don't know how to figure it out, to save yourself some time, the easiest way to do this, to simplify the fraction, is using your graphing calculator. So you're going to go to your graphing calculator and type in 315 divided by 180. You're going to get 1.75. So now what you're going to do here is you're going to click the math button. And that first option that is highlighted in pink on my calculator, the triangle with FRAC, that's going to change your answer into a fraction, and it's going to change it to fraction in simplest form. 7 over 4. 7 divided by 4 is still the same thing, 1.75, except it's in simplest form. So this is equal to 7 over 4. and pi stays in the numerator. So our answer is 7 pi over 4 radians. We're going to do the same thing for number 20. So first we're going to change it to a fraction. We're going to multiply by pi over 180. And we get negative 115 pi over 180. So same thing, go to your graphing calculator. These are both divisible by 5, but you can go to your graphing calculator, type in negative 115. Negative 115 divided by 180. You get this value. You're going to click the math button, select the first option, and it changes it to a fraction for you. Negative 23 over 36, that is in simplest form. So this is negative 23 pi. Pi stays in the numerator, over 36. That is your answer in radians. For number 21, again, the same thing. Change it to a fraction. Multiply by pi over 180. You're going to get negative 390 pi over 180. So we're going to go back to our graphing calculator. Type in 390 divided by 180. And use the math, and the fraction function changes it to a fraction for you. I forgot to put negative 390, but this is negative 13 pi over 6. Negative 13 pi over 6. Okay, so just remember, multiply by degrees times pi over 180. And then when you're converting from radians into degrees, you're going to multiply by the reciprocal of that. So you're going to multiply your radians. When you have radians and you want to change the degrees, multiply radians by 180 over pi. And the way you can try to remember this is you want to get rid of pi. So having pi in the numerator by what you're multiplying will get rid of pi. They'll cancel each other out, right? So we're going to take our radians and we're going to multiply by 180 over pi. So we have 17 pi times 180. So you're going to go to your calculator, type in 17 times 180, and we get 3060 pi. 17 times 180 is 3060, and then pi. And then in the denominators, we have 9 times pi, which is just 9 pi, right? So the pi's cancel each other out, and we're just left with 3060 divided by 9, which when you do that math, you get 340 degrees. For number 23, we're going to do the same thing. So multiply by 180 over pi. It's negative, right? So we're going to do 8 times 180, which is 1,140 pi, over 9 times pi, which is 9 pi. And again, the pi, this is negative. The pi's cancel each other out, so we're just left with 1,140 divided by 9, which is negative 160 degrees. And then for the last one, number 24, we're going to, again, multiply by 180 over pi. So we're going to do negative 29 times 180, and we get negative 5,220 pi over 9 times pi, which is 9 pi. Pi's cancel each other out, and we're left with negative 5,220 divided by 9. So do that on your calculator, and you will get negative 580 degrees.